Hello, my name is J.J. Billings, and I am the lead architect and developer of the NEAMS Integrated Computational Environment. I'm very happy and proud to announce, on behalf of the entire team, the release of NiCE 2.0 today. Actually, the release is tomorrow, but we're filming the video a day in advance. This leads to the question, why would we film a video for a software release? Well, we wanted to report our progress to our program managers, but we wanted to do it in a way that was much more dynamic and interesting than simply writing a report, which would be hundreds of pages on static, flat pieces of paper. So, this, combined with the fact that we'd been asked to do a number of demonstrations, led us to develop a video. So we filmed it, and we hope you enjoy it. We're going to cover a number of things in the video today. We're going to start by talking across some slides about NiCE. We're going to cover some fun facts about NiCE. We're going to do a tour of our web page so that you can see all of our different types of documentation. And then we're going to do some demonstrations of NiCE that we believe will help you understand what we're doing and where we're trying to take the software product. I hope you enjoy the video. So what does NiCE do anyway? NiCE was originally designed or conceived about 3 years ago as part of the frameworks effort in capability transfer under David Bernhold. At the time, we came up with a loose description of things that didn't fit a software framework, but fit more of the environment that encompassed all of the modeling and simulation activities. Over time, by working with the reactors product line and the fuels product line, we defined a lot of different things, some of which are listed here, that are important for that environment. And that environment, of course, being NiCE. The biggest thing that we identified at the time, although this certainly isn't the thing that NiCE is best at, is job launch and monitoring. A lot of the subject matter experts wanted to do this a lot more efficiently than having to learn the shell and log into Jaguar. So we've put a lot of time into developing that and making it pretty easy. I'm going to show you some examples of that when I do the demonstrations, but I'm not going to show you an example of the monitoring. We actually do have a C++ library that can be coupled into any C++ code, and we're developing Fortran and C bindings for that to facilitate monitoring, real-time monitoring. This will allow the simulation codes to call back to NiCE when they're running, but we're not going to show that today because we don't actually have any NEAMS examples of that running. We're also pretty good at managing inputs, and we're getting better at dealing with 3D geometry. We're not so good at dealing with materials and meshing. That's in part because both of them are very hard problems, and because materials are different for almost every code. We do some other things. We're starting to do some other things like data analysis and visualization. We are coupled to Visit. Some of the things that we can do with Visit are not optimal. They're not like the way that Visit normally does them. And so we've engaged with the Visit team through Mark Miller to look at some of those issues in FY13. We also manage all of the files that we create in a way that makes it easy for people to find them later. We put them in a place and we label them, and we can collect other information about them for provenance. One of the things that I have listed here, the next bullet I should say, is adding code to new software systems. This was something that was really big when there was one framework in NEAMS. Since the plan is shifted to 2 separate product lines these days, this particular task has been deprioritized. But I leave it here because NiCE does this very well on some other projects, and I thought it was important to show that its origin was actually in NEAMS. And finally, NiCE can actually extend itself by adding new job launchers to it. There's a UI that I'll show you for doing that, and it makes a launcher, and you can launch it. This is particularly interesting and useful if you're working with someone's code and you want to be able to run it, but you don't want to have to work the shell. On the right, I have a couple pictures here. One of the geometry editor in NiCE showing an assembly, and the one at the bottom is actually our Reactor Analyzer but this is showing an astrophysics picture from one of my nuclear network codes that calculates rates and populations over time. Some fun facts about NiCE. One of the facts that I left off of here is that NiCE is based on Eclipse. But it has been also developed at Oak Ridge National Laboratory. Actually, let me clarify that. The core pieces of NiCE are solely developed at Oak Ridge National Laboratory, and we rely on the Eclipse platform from eclipse.org. And we've been developing this about 3 years now. The first year, the first 2 years were requirements gathering and the development of the 1.0 version, and the last 14 months have been the development of NiCE 2.0. We have 9 team members, 7 developers, plus a couple support staff. We've got lots of code. 80% of it's in Java, and it's very well documented. We also have lots of out-of-source documentation for those who don't want to read through the code. We have a wiki, we have our UML model, and we also have JavaDoc, which is a form of documentation that actually goes through and collects everything out of the code. We're also working closely with friends in other offices and areas, such as EERE, and CASTLE, of course, and ORNL work for others. This is on everything you can imagine. We get to work on a lot of different things. Actually, our best deployment of NiCE to date has been with some quantum information activities, and it's very, very nice. So we actually have a 2-year development plan on NiCE 2.0, and that started about 14 months ago, and the first year of that culminates, I suppose, today. And there are too many things, too many goals from FY12 for us to list. But the focus for FY12 was on developing the infrastructure to support many codes and users. I want you to remember, when you're seeing everything that I show later, that this year was about developing infrastructure. Our goals for FY13 focus solely on deploying NiCE for the product lines. This has always been the plan since FY11. The plan was decided upon at the time by our sponsors. It was also decided upon by the reactors and product line leads in a meeting with me at a planning meeting. And we're particularly looking forward to integrating or developing plugins for NEC 5000, and we're very hopeful that we'll be able to work with the Moose Bison team at Idaho. This activity is not officially planned yet, but hopefully soon. So the remainder of the video. The first thing I'm going to show you is a slide on the basics. I want you to see some of the buttons and areas in NiCE before we run it so that you'll understand what I'm clicking and why. And this is a single slide with just some instructional information. After that, I'm going to give you a tour of our website. There's a lot of content at our project page, lots of documentation. There are bug trackers and bug reports and known issues. The website is also where you download NiCE, so I want to go through that in some detail. After that, I'm going to show you some demonstrations. In particular, these 5 things. Now, the last 2 on the list are not perfect. We acknowledge that, and we're really looking forward to working on them over the next year. These 2 are in active development, daily development. The top 3 on the list are really quite stable. And actually, the very bottom one on the list is it still has a lot of ongoing work on it, and as I mentioned earlier, we're trying to engage with the visit team to look at optimizing.
Let's talk about the basics of NiCE. When I say the basics here, I mean the basics of operating and using NiCE. We'll start with the Create an Item button and the File menu. Whenever you want to perform a particular task in NiCE, you create something. In fact, NiCE is all about creating things called items. Simply click the button, the little button that's shown here at the left, or click the File menu and choose Create an Item. When you create an item, a box shows up and you can choose an item from that list. When you choose from the list and hit OK, the item that you created appears in the item viewer, depicted here in the middle left of the screen. There are a couple other views that are important to see. There's the shape tree view for when you're creating a geometry, and there's the transformation view. The differences between the two views are that the shape tree view allows you to create and manipulate shapes, and the transformation view allows you to manipulate the properties of shapes. The final piece that you need to know about before working with NiCE is the form header. There are a lot of different elements of this header that are important, and I'll go over a few of them here. In particular, the processing box. In the bottom right of the screen, you see a box with a label that says process, and it says launch the job, and it has a go button. You'll see how to use this in NiCE in a minute, but it's critical. Next to this, on the left, there's a status bar. At the moment it says ready to process, and it's just next to the name of the de novo MP launcher here. That status bar changes over time, and so you have to watch it for instruction.
Okay, so this is our project page. And in spite of what the URL at the top says, I would like to say that the address that you see in the slides and that you see in emails and other things from me redirects to this page. So the shorter version, niceproject.sourceforge.net, will always get you here. As you may recognize, this is actually a MediaWiki installation. It's the same software that runs Wikipedia. And we have everything here. We have a lot of articles, all sorts of stuff, a lot of which most people won't need. And we actually keep a log of our status meetings. Everything we do every day goes onto this page. So I'm going to start by looking at the tasks here at the top. These are the ones that are really important if you come to the web page. Getting NiCE is the article. It is the source for downloading and installing NiCE. I'll go through that one in detail in a moment. It's the instructions. It's the instruction manual. About NiCE is our vision document, actually, and the only thing missing from our hard copy vision document in this version is the table of sponsors. And admittedly, that's because I have trouble with MediaWiki tables, but I'll get to that at another time. Our development team is the next set, and it's actually, I'll come back around to this at the end of the talk, but our developers are a lot of really cool people, so if you want to get to know us, check out this page. The next thing is a very important one for a team of 9 people, and at least 7 of whom who edit regularly. If you need MediaWiki resources for how to edit a wiki, they're here, and I think that some of the people who are viewing this may actually end up contributing, so this will be very important. Our next 2 items are quite critical: known issues and bug reports. If you click the bug reports link, it will take you to a bug reporting page here, and this is our tracker. And actually, don't look at these bugs. They're all closed. They're not actually open. But if you want to submit a bug, you can just click Add New and describe the bug and put it there. And I really encourage you to do this if you find a bug that is not listed in our set of known issues. Now, about those known issues, we'll take a look here. There are a lot of things in NiCE that we are very well aware of and that we're working really hard to fix. I have some of them listed out here for persistence. One of the big things about NiCE at the moment, and this is only for a couple more weeks, I want to stress that hopefully we will have this available soon. NiCE does not save the items that you create at the moment. It has an embedded database in it, but we're trying to do a little bit more testing before we enable that. We don't want early users of the 2.0 release to do a whole bunch of stuff in the database, and then we have to change it and they lose those items that they've created. So for the moment, we're not going to store them, and hopefully very soon we'll have a patch to the website that will fix that. Other things are covered here, and I'll let you go through them at your own pace. But look here, if you're going to report a bug, it's good to look here to see if we already know about it. If we do already know about it, it would be great if you emailed me just to let me know that it matters to you. So let's go back and look at what it takes to get NiCE. Now, these instructions are up to date as of Monday, I believe. I did write them myself. I'm going to go through the simple version at the moment. I'm not going to worry about installing Visit. That's something that it takes a little more time. If you want to work with NiCE and you can't get Visit going, let me know. There are Visit binaries that are very easy to get and install, and I can help you with that. So to get NiCE, make sure that you have Java on your machine. Particularly if you're on a Windows machine, you need Sun's Java. If you're on Linux or Mac, you can use the OpenJDK version of Java. And then you need to download the binary package from the Files folder on the NiCE SourceForge page. So let's take a look at that real quick. Okay, so here is the Files page. Now at the moment, you'll notice in the list here, you don't see NiCE 2.0. And the reason for that is because we're filming the video a day in advance. So tomorrow, you'll actually see the 2.0 release and you'll be able to download that to your machine and run it. The nightly releases are uploaded, their versions uploaded, compiled and uploaded nightly. Actually, every morning at 4:30 in the morning, our system pushes the newest releases to the SourceForge server. And the serialized plugins package is something for more advanced use that we're not going to cover today. Now for me to run NiCE, I would download this zip file. I can click that because I'm a Linux user on a 64-bit Linux. And at some point it'll throw up a box that says you may download me now. If it doesn't download immediately, you can click the direct link and it will pop up. So it pops up and you can say save. I'm just going to pop it open and look at it real quick and show you what's in here. Kind of the last thing I want to show you on this getting NiCE bit is the structure of the folder. If you get the NiCE zip file and unzip it, this is the product structure, or the file structure. You need to click on the NiCE executable. On Windows, this is nice.exe. On Linux, it is just NiCE. Now, I'm actually not going to run this version. I'm going to run the 2.0 version, so we will not touch that. I'll go back to our wiki real quick. What do you do if NiCE fails? I wanted to cover this here. If it fails, email me. And if you believe that you've identified a bug, you can also report it to our bug tracker. So that's the tour of the website, and that's the quick how do you get NiCE. If you're interested, there are all sorts of other detailed documents down here that show you how to do other things. For example, if you're a glutton for punishment, you might check out Compiling NiCE from Scratch. That's a very detailed article on how to build NiCE. I have NiCE open here, and I'm going to show you how to launch a job. Hopefully you see some elements that you recognize, like the item viewer, the shape tree view, the transformation view, and the create an item and file menus. I'm going to select the create an item button, and the item selector menu pops up. Now I could show you how to launch NEC 5000 or Denovo MP, but those take a long time to run, and I actually just want to do something short so that you learn the workflow of using NiCE. I'm going to run the file command in Linux. I know this is not so useful for nuclear energy, but I want to show you how to do it, and you can come back and run the physics ones later. Now the file command launcher pops up. It has the header here, It also has the list of input files that you can select. You can choose ampdata.silo from the list, and we can run it on Antecessor, which is my local machine. We can save that, and when we hit the Save button, it says Ready to Process. Let's choose to launch the job and hit Go, and now it says it's done. If we look at the output files and data, we'll see that a file has appeared here, and if we click it, it'll tell us what the file is. Now, let's change the platform to some remote machine, such as Habilis, which is the NiCE server. Click Save, and now it tells us we're ready to process again, and let's launch the job. This time it asks for my username and password, which I will gladly enter. It takes a little longer to process, but then it finishes. And if we click the file again, we can see that the output changes. The next thing that I'm going to show you is how to create your own job launcher. Once again, I create an item and I choose Job Profile. I hit OK, and a very complicated form pops up. If you fill out this information for a particular job, let's say in this case we want to launch the ls command on Linux, you can set some other parameters such as the host name and the data files. You can set launch parameters, and if this was a multi-threaded application, you could enable OpenMP, and if it was multi-processing, you could enable MPI. Actually, at the moment, enabling these does not enable the user to change the values. We've set it that way at the moment because we're still doing some testing with code teams so that users can't enter values that cause their codes to go insane. But NiCE is fully aware of MPI and OpenMP. Now, if I put some parameters in here, I'm asked to save it by the little star and the buttons. I hit Save. I go to the Process menu and I choose to create a job launcher, and I hit Go. It did some work and then it said it was done. If I restart NiCE, this will appear in the list. I'm going to show you how to launch multiple jobs at the same time or in sequential mode. I'm actually only going to focus on sequential mode for this demonstration because I don't have a lot of time, but I hope that you'll play around with NiCE and try this yourself. You'll notice that the items we previously created are gone. I restarted NiCE during the slide transition so that you could see that the ls command that we just created actually appears in the list of jobs we could launch now. It's fully configurable just like the others, and it's absolutely usable. Let's forget about that for now and let me show you our multi-launcher. If I open this, I create another item and I create a multi-launcher. A lot of things pop up on the screen. This is a standard pattern called a master details pair. I'll spare you the details, but basically it lets us create job listings here. We click Add. We'll add a couple trusty file command launchers. If I highlight one, the parameters for those appear here. And I can configure different files for different launchers. I can execute in parallel or I can execute sequentially. And for this, because I want you to see that it steps through both jobs, I'm going to launch sequentially. And I can also execute on a remote machine, but I'll leave that as an exercise for the user. It works just like the execution for a remote machine in the standalone mode, but it asks you for your password for each machine. Let's choose to launch, and let's hit Go, and it says it's done. If we look at this, we have output from 2 file command launchers, one for the ampdata.silo file, and one for the OGG data. This is kind of a funny example because I'm showing you how to do this with a file checker, but we actually use this every morning to run de novo MP. One of our team members tests it, one of the NiCE team members tests it, and it's plugins for NiCE using the multi-launcher. And the really great thing about that is that he sets up the validation problems and launches them. I think it takes him about 30 minutes to run all of these on one of our big machines. Now I'm going to show you how to create a model or an input file with NiCE. Once again, we create another item, and in this case, we'll pick de novo MP model. A lot of options pop up on the screen for the de novo MP model. One thing I'd like to point out is that we realize that having yes-no split like this on the screen is not the most useful or ergonomic way to deal with it, and we're going to refactor that, but it's sufficient now to explain the exercise as is. Each column here represents a different set of options that can be specified for de novo MP. If you look along the bottom, there are separate tabs, and you can click a tab and additional options appear. If we change one of the numbers, a parameter such as initial temperature guess, to some unacceptable value, NiCE tells us that that value is unacceptable. Correcting it corrects the value. This works just like the job launcher. Once we edit some parameters, we hit save, we go to the process bar, and we choose how to write it out. In this case, we write to a key value pair output and hit go. And we're done. I'm going to demonstrate the geometry editor for you very briefly. And you create the geometry editor in the same way you create other items, just by creating an item and choosing geometry editor. This takes a second to load up because the 3D geometry libraries have to unpack. The screen stays gray like that for a little bit, but eventually it turns black, and you'll see the +C, +Y, and +X stickers appear on the screen. I'm not going to take a lot of time to speak to you about this. I'm just going to show you how to add a couple shapes and move around, and also to change their size. So we can add a sphere, and we can add a cube, and if we want to move that cube, we can translate it, and that'll translate it in an X. And I should say that in the transformation view, I clicked on the X box, and now I click on the Y box, and I can use the arrows to move it up. I can also, if I want to move it in Z, I can also type, and that will move it as well. If I want to move around the screen, I use the WASD keys and the mouse to move around. I can duplicate these shapes. So now I have two spheres. This one's laying on top of itself, but I can move it. I can also make groups if I want to group some shapes together. At the moment, we put these into a union. And what I'll do is I will add a cylinder to the union. I'm going to move the cylinder up. I'm going to move it in X. I'm going to look over there. Actually, I'll move over there. Now I'm going to duplicate the cylinder. Duplicate doesn't move it off base, but let's actually replicate the whole union. And let's replicate it, I don't know, 50 times. And I will shift it in +Y. I'll shift it by +1. And there we go. We have a bunch of little cylinders stacked on top of each other. Now, how do I know they're stacked on top of each other? I can click the replication in the shape tree view. I can choose one of the cylinders, and I can see it there. I can move back and forth and select across them. And I can do other manipulations with this. I'm going to conclude the demonstration here because we have a much longer video. It's about 2.5 minutes on this showing how to create an assembly. And I do want to note that we realize there's a lot of work left to do on this. Some of the things we want to put in include picking. So right now I'm clicking on the screen, but that cylinder is not being selected. If I click on the cube, that cube is not being selected. We also want to add tagging so that you right-click an item here in the view and you can set shape properties, you can set material properties and boundary values. And we'll also hook this up to a mesher. At the moment, about the only thing we can do with this is actually export to a native format. This will let us export to NiCE's XML format. And we are targeting other formats with that as well, and hopefully we'll have some of those online and in production soon into the FY 2013. The next piece that I'm going to show you is our Reactor Analyzer. This is an item in NiCE that's designed to perform data analysis and post-processing on simulation data from nuclear reactors and fuel simulations. At the moment it's rudimentary at best, but we hope to expand it to include much more tailored analyses than just coupling to visit. We only support silo files at the moment because NiCE is only coupled to visit as an output analysis source. Now I do realize that visit supports way more files than this, but we haven't played around with them at the moment. We don't want to just randomly throw files at it, so we're going to give it a little thought before we just give it everything. This looks a lot like the multi-launcher, and actually under the hood it's the same code. It is the exact same code. I need to choose an available data source here. I choose the de novo mpdata.silo file. I'm going to save that. Now it's taking a little work to perform this task because this is a heavyweight task. But the actual problem here is that I'm running so many things on my machine at the moment. So when I create some analysis artifacts here, let's pick the temperature, and then let's pick one of these specific power things. When I create these, it's going to take a while to process. That's not actually NiCE. That's my machine being really slow because of all the AV equipment hooked up to it. So we've selected these two analysis configuration pieces. We've selected a data file. Let's go ahead and choose Generate Analysis Artifacts as our processing task. Let's hit Go. And it tells us that it's processing some stuff. As soon as this is finished, we'll click over to the Analysis Artifacts page and have a look. In the meantime, I'll tell you that some of the things we're working on for this they come from the field of data mining and machine learning. It looks like we're done here. And some of these things are including anomalous pin detection. So if we've got something crazy, we can look at power profiles and pick out anomalies there. Hopefully we'll have something cool to show in a while. But for now, here we are. We've generated these things, and you can see that the temperature mesh is a little different from the specific power mesh. If we actually had a better angle, you could see it quite a bit better. That's our Reactor Analyzer. I'm really hoping that some of the folks in NEAMS have suggestions for particular types of analyses that we could do from data. The idea is to do this automatically so long as they pick the file and tell us what they want out of it. If you have suggestions, please email them to us. We'd be really glad to try to incorporate them into this tool. With that, we'll conclude the demonstrations and we'll finish up. If you have any questions, I encourage you to contact me at my email address or our website below. I also want to say that at this point we have more than 190 releases and counting. We've been continuously releasing versions of NiCE 2.0 to our website for at least 190 days. So we're very excited about this project, and we're looking forward to working with everyone next year. I want to acknowledge the other people that helped on this: Andrew Belt, Mike Guidry, Forrest Hull, Eric Lingerfelt, Greg Lyon, Alex McCaskey, and Niti Pokrial. This is a very good team that we have. With that, I'll sign off. I hope you enjoyed the video and found it informative. We're very proud of NiCE, and we're looking forward to working with the NEAMS program in FY13 to deliver even more value. Everyone on the team is excited to begin working on plugins for codes from the product lines. Thank you very much for watching, and if you have any questions, please don't hesitate to email me.